Hi everyone! In the previous topic, we have learned how to create mathematical models in the form of differential equations which are obtained through the application of some physical laws. For example, we can use Newton's second law of motion to obtain or formulate a differential equation. Or if we have an electric circuit, we can apply KVL or KCL. However, aside from these existing physical laws, differential equations may also have geometric origin. So if you recall, in one of our previous topics, you have also learned that the general solution of a differential equation represents a family of curves. So, if you are given a family of curves, its differential equation can be obtained. And it's also possible that a known solution will be given, and then from the general solution, we can obtain its differential equation. And this would be our topic in this video. That is, to obtain the differential equation from a given solution. And that solution would be a general solution. So, in the succeeding examples, I will give you several known general solutions and obtain their corresponding differential equations. So, this can be done by eliminating the arbitrary constants in the given general solution. And that is why a lot of professors would discuss the topic called elimination of arbitrary constants. However, personally, I'd like to call this topic formation of differential equations from known solution, so that the topic would be more purposive, okay? So from the topic itself, the formation of differential equations, dun pa lang, alam na agad natin kung ano ang purpose, kung ano ang ating goal. However, this topic again is the same as the elimination of arbitrary constants. And now, to illustrate how differential equations are formed from a given general solution, let us have an example. So this is the first example. Find a differential equation whose general solution is given by x cubed minus 3x squared y equals c. This expression represents the general solution of a differential equation. And our goal this time is to find that differential equation whose solution is already given. So if you may recall in our previous topic, dati ang ginagawa natin is given ang isang differential equation, hahanapin natin ang kanyang solution. But this time, we are actually doing the opposite. We are given a general solution, and from this general solution, we now find the differential equation. So how can we do this? Okay, so if you recall that if we are given a differential equation, we integrate in order to find the solution. So since this process is just the opposite, then we also do the opposite process. If we are given the solution, we need to differentiate to obtain the differential equation. And kagaya ng ibang prof, no, ang sinasabi nila is ang topic daw is elimination of arbitrary constants. So we will actually differentiate to eliminate the arbitrary constant. And after we have eliminated the arbitrary constant, we will be left with the desired differential equation. Okay? So, isolve na natin ang problem na ito. Sir, ilang beses po ba ako magdi-differentiate? So, the number of times you will differentiate is equal to the number of the parameters. So, yung parameters na tinatawag is yung arbitrary constant, which is ito. No? So, in this expression, we only have one arbitrary constant. That is why we will differentiate this expression once. Differentiating, we will get, term by term, mag-differentiate tayo. So, we have 3x squared minus. Okay, so kapag may minus sign, lagyan agad natin ang parenthesis para hindi tayo magkamali. No? So here, we will be differentiating two variables. So this can be treated as or we can use the derivative of a product because here, x and y are both variables. So we will apply the derivative of a product first. So we copy the first term, u. So we have 3x squared. And then the derivative of the first term, dv. So the derivative of y with respect to x is y prime. And then plus y times the derivative of 3x squared, which is 6x, equals, of course, 0. Okay? So we now write this as 3x squared minus 3x squared y prime, and then minus 6xy equals 0. So if it's possible to simplify the expression first, then simplify it. So do we have a common factor here which we can cancel? Okay, so as we can see here, 3x is a common factor. So if we divide the entire equation by 3x, we will be left with x minus x y prime, and then minus 2y equals 0. Okay. So actually, we can combine the terms without the derivative. So these two terms, x and negative 2y, do not have derivative terms. So we can write this as x minus 2y minus x y prime equals 0. So in this expression, the derivative is explicit. Okay, but another way of writing this is in terms of the differential form. Okay, so in order to convert this equation into its corresponding differential form, we need to express y prime as dy over dx and multiply both sides by dx. Okay, so I will just copy paste x minus 2y and then minus x, and then I replace y prime with dy over dx equals 0. So I can now multiply both sides by dx, so I can write this expression into its corresponding differential form. So I will have x minus 2y multiplied by dx and then minus x dy equals 0. Okay, so this could be your final answer, or this could also be your final answer. The difference is that this is in derivative form, because here we have the derivative explicitly written as y prime, but here we have what we call the differential form. So this is the differential equation in its differential form, and this is the differential equation in its derivative form. So this is now the differential equation whose solution is this. Actually, we can prove that this is a solution. No? How? So, try solving this DE. If you solve this, you should be able to get this solution. Okay? So, let us have some more examples. Example number 2. Find a differential equation whose general solution is given by y sine x minus x y squared equals c. So, here we have 1 arbitrary constant. And because there is only one arbitrary constant, we will differentiate this once. So, take note that this is again a product. So, we will apply the derivative of a product. U times the derivative of V plus V times the derivative of U. So, differentiating, we have y, and then the derivative of sine x is cosine x plus sine x times the derivative of y. Of course, with respect to x, that's y prime. So here we have sine x times y prime. And then minus, so again, pag may minus sign kang nakita, gawin mo agad siyang may parenthesis para hindi ka magkamali ng sign. So again, this is the derivative of a product. So we have x, and then the derivative of y squared with respect to x is 2y, and then y prime. Okay, and then plus y squared and times the derivative of x, of course, that's 1. So, hindi ko na ilalagay yung 1 doon. And then equals the derivative of c, which is an arbitrary constant. So, this will give us 0. Okay? So, let us now rewrite the expression that we have obtained. So, we have y times cosine x plus sine x multiplied by y prime minus 2xy y prime, and then minus y squared equals 0. So, just like what we did kanina, yung mga terms na walang derivative, pwede nating pagsamahin. So, we can group y cosine x and then this term. So, y cosine x minus y squared and then plus. Pagsamahin natin lahat ng term na may y prime. So, ito yung dalawang terms na may y prime. So, I have the quantity sine of x minus 2xy, and then y prime equals 0. So actually, this could be a final answer, no? Na naka-derivative form. Okay? However, we can also express this in terms of the differential form. Again, this y prime is your dy over dx. So if I multiply both sides by dx, what will be left here is only dy. And these two terms would have a multiplier dx. Okay, so let's do that. Y cosine x minus y squared, and then dx plus sine of x minus 2xy, and then dy equals 0. So this is now our differential equation expressed in its differential form. So again, if you try solving this differential equation, if you know how to solve it, you should be able to get this answer. However, at the meantime, hindi pa tayo marunong mag-solve ng differential equation. So, yung pagsosolve ng ganitong klaseng differential equation, that will be discussed in the next module, module 2. So, at the moment, ang ginagawa natin is, binibigyan tayo ng solution ng DE, and from that solution, we obtain the differential equation. So, next example. Find a differential equation whose general solution is given by x equals c sub 1 times cosine omega t plus c sub 2 sine omega t. So, unlike the previous examples, here our dependent variable is x and our independent variable is t. So, here, omega is a constant and the arbitrary constants or parameters that we have are c1 and c2. So, since we have two arbitrary constants, we have two arbitrary constants, this implies that we will get two derivatives. Okay? So, we will get the derivative of x with respect to t, the first derivative, and then after that, we will get the second derivative of x with respect to t. Okay? So, I will just be using the that notation because we are differentiating with respect to t. So, what is the derivative of this term? So, our cosine term here has a multiplier. So, this multiplier omega will be the multiplier of c1 when I differentiate. And the derivative of cosine, of course, is negative sine. So, I will get negative omega and then c1 and then sine omega t plus. So, again, in this term, the constant omega will just be a multiplier to omega c or to c2 if I differentiate. Okay, so I will get omega multiplied by c2. Itong c2, it's cool and clean because it's c2. Okay, and the derivative of sine, of course, is cosine. Cosine omega t. Okay, so we have the first derivative of x with respect to t. Again, we have two arbitrary constants. That is why we will differentiate twice. We don't derive, actually, the process is differentiation. So, when you say kung ikaw ay kukuha ng derivative, the correct way of saying that in English is you will differentiate, not you will derive. Magkaiba yun. Okay? So, we will now differentiate this x dot to get x double dot. Okay? So, the derivative of sine is cosine. And this omega will be the multiplier to this term. So, we will get negative omega, magiging squared na yan. Negative omega squared c1, and then the derivative of sine is cosine omega t, and then plus. Oh no, this is not plus. Why? Because if we differentiate cosine, we will get negative sine, and this omega will be a multiplier to this omega, so we will have omega squared and then c2, and then the derivative of cosine is negative sine omega. Okay. So, actually, we have a common factor here. Negative omega squared is a common factor. So, we can simply write this second derivative of t or x with respect to t as negative of omega squared. And then, so we have here the common factor. And then, copy the rest. C1 cosine omega t. And then, plus na yung term dito. C2 times the sine of omega t. Okay, so we have the second derivative of x with respect to t, negative omega squared times the quantity c1 cosine omega t plus c2 sine omega t. Now remember again, our goal here is to find the differential equation by eliminating the arbitrary constants c1 and c2. But how are we going to eliminate c1 and c2? Okay, so if you will notice, this term here is just the same as the given expression. C1 cosine omega t, C2 sine omega t. Yes, ayan no. Tingnan mo. Magkamukha sila. They look the same. Thus, I can replace this entire expression with x and rewrite my differential equation as x double dot equals negative omega squared x. So this is now my differential equation that is free of arbitrary constants. Okay? So, if you want to write this in terms of derivatives, na kitang-kita mo yung dependent variable using the denotation, I can write this as d squared x over dt squared equals negative omega squared x. Now, if you will recall, this differential equation may look familiar. In one of our previous topics, I mentioned that this differential equation, if you notice the left-hand side, if x represents the position, this term, the second derivative of the position with respect to t, represents the acceleration. Yes. So, yan ay acceleration actually. Ito. And if you recall, this is the acceleration of a body in simple harmonic motion. Okay, we can also express this. We can transpose this part of the equation to the other side. So, it's now equal to 0. D squared x over dt squared plus omega squared x is equal to 0. So, this is also another way or one way of expressing your final answer. Naka-equate siya sa 0. And once again, this differential equation is a familiar differential equation. This differential equation represents the acceleration of a body in simple harmonic motion. Okay? So ngayon pa lang ha, alam na natin, kapag simple harmonic motion, ganito pala ang differential equation. And pag ito ay iyong sinolve, dapat ito ang makocompute mo. Next example, find a differential equation whose general solution has the form y equals c1 plus c2 e to the negative 3x. So if you notice, in this expression, we have two arbitrary constants, c1 and c2. So to get its differential equation, we need to eliminate the arbitrary constants c1 and c2. And we can do that by differentiating. How many times are we going to differentiate? Twice. Why? Because we have two arbitrary constants. Okay, so let's do the solution by first getting the derivative of y with respect to x. So let's get y prime, sabay-sabay. The derivative of this constant term is 0. And then if I differentiate this, I will get negative 3 multiplied by c2 times e to the negative 3x. So this is my first derivative. So let's now get the second derivative. Okay? So if I differentiate this term, negative 3 times negative 3 will give me positive 9. So 9 c2 e to the negative 3x. So now, how are we going to eliminate this arbitrary constant c2? Actually, these are two similar terms. So we can add them in order to eliminate c2. So I can multiply this by 3. So let's call this equation 1. And let's call this equation 2. If I multiply this by 3, then I will get a term here, negative 9c2 e to the negative 3x. And if I add them together, the term containing c2 will vanish. Okay, so what we will do is to multiply equation 1 by 3. Okay, 3 times equation 1 and then we add it to equation 2. So I call this the elimination method. Okay. So, 3 times y prime is 3y prime equals, this times 3 is negative 9c2 e to the negative 3x. So, now we will add it to equation 2. So, dapat dito plus. And then, copy equation 2. So, we have y double prime equals 9c2 e to the negative 3x. So, if we add the two equations, this does not have any corresponding similar term there. So, it's just 3y prime. And then, this y double prime has no similar term above. So, we just write it as y double prime equals. Now, if I add this right-hand side of the equations, I will get, of course, 0. This term will cancel. So, I can now have my equation here. Okay? Tapos na ang laban. Meron na tayong differential equation. Y double prime plus 3y prime equals 0. So, this is now the differential equation whose general solution looks like this. Okay, so once again, in this topic, we are given a known general solution. And what we are doing is we are obtaining the differential equation of that general solution. Okay, so if you notice, this equation is linear and has a constant coefficient 3 and 1 there. Okay? Next example, find a differential equation whose general solution is the form x plus c1 e to the x plus c2 e to the negative x. So, just like the previous example, this general solution contains two arbitrary constants. That's why, to find its differential equation, we have to differentiate twice. So, let's write the first derivative. The first derivative is derivative of x with respect to x, of course, that's 1. Plus, the derivative of this term, so we have c1 e raised to x. Plus, the derivative of this, magne-negative siya ngayon. Lagyan ko na lang dito ng negative. Negative c2 e to the negative x. Okay, so let me rewrite this as 1 plus c1 e to the x minus c2 e to the negative x. Okay, now, let's get the second derivative. The second derivative is, for this term, the derivative is 0. And here, the derivative is c1 e to the x. And then, negative of negative will give us a positive term, c2 e to the negative x. Okay, so we now have the two derivatives, y prime and y double prime. So now, how are we going to eliminate c1 and c2? For example, let us call this equation, equation 1. Let's call this equation 2. And let's call this equation 3. Okay. If we add equation 1 and equation 2, this term, c2, will vanish. Okay? So, I add equations 1 and equations 2. I just copy y equals x plus c1 e raised to x and then plus c2 e raised to negative x. And then I copy equation 2. Y prime equals 1 plus c1 e raised to x minus c2 e raised to negative x. Okay, so adding these two equations, I will add them. So, I have y plus y prime equals x plus 1 plus c1 plus c1 is dalawa na siya. 2c1 e raised to x. And then, of course, this term will vanish. So, here, the only arbitrary constant left is c1. Okay, so what do I need to do? Here, in equation 2 and in equation 3, I can also add them to eliminate c2. If I add equations 2 and 3, copy ko muna para hindi kayo malito. So, y prime equals 1 plus c1e raised to x minus c2 e raised to negative x. And then for equation 3, we have y double prime equals c1 e raised to x plus c2 e raised to negative x. Okay, so now I will add these two equations. So we'll have y prime plus y double prime equals 1 plus C1 here. We have 2 C1 e to the x. And then, these terms will vanish. Pag inad natin, magsi-zero na yon. Okay, so let's call this equation 4 and let's call this equation 5. Okay, now if we notice, in equation 4 and equation 5, the only arbitrary constant left is C1. So, I can subtract these two to eliminate C1. Okay, for example, I have equation 4 minus equation 5. So, let's write it. Y plus y prime equals x plus 1 plus 2c1e raised to x. And then, for equation 5, minus yung gagawin natin, minus. Equation 5, we have y prime plus y double prime equals 1 plus 2c1e raised to x. Okay, so let us subtract term by term. Here, we do not have any term containing y, so y minus 0 is just y. And then y prime minus y prime, these two terms will cancel. Okay, and then 0 minus y double prime will give us negative y double prime equals, so here I do not have any term containing the variable, wala akong power function na x, kaya x minus 0 is just x. And then 1 minus 1, these two terms will cancel. And then of course, 2c1 e to the x minus 2c1 e to the x, itong dalawang terms na to magka-cancel na siya. Okay, so what will be left is this equation, which is, ito na yung differential equation na ating hinahanap. Ano? So, the proper way of writing a differential equation is to arrange them in order of decreasing derivatives. So, ito ilipat natin sa kabila at siya yung unahan natin kasi siya yung highest derivative. So, y double prime minus y and then plus x equals 0. So, this is now the required differential equation. Ayan. So, if ever, isosolve mo ang differential equation na ito, dapat ganito ang makukuha mong solution. But again, as I have said kanina, at this moment, hindi pa tayo marunong mag-solve ng ganyang DE. Ano? Sa module 3 pa natin ito isosolve, module 4 rather. Okay? So, pag-aaralan natin yan in the succeeding topics. Now, let us have this example. Find a differential equation whose general solution has the form y equals ae to the 2x plus bx e to the 2x. So, dito meron din tayong dalawang arbitrary constants, a at saka b. So, para makuha yung kanyang differential equation, we need to differentiate twice. O, gawin na natin. Let's get y prime. Y prime equals, the derivative of this will be 2a e raised to 2x. And then plus, take note that this term is a product. No? So, this is my u and this is my v. So, derivative of a product. So, bx u times the derivative of e to the 2x, which is 2, e to the 2x, and then plus e to the 2x times the derivative of bx, that's just b. b times e to the 2x. So, this is now my y prime. Let's just rewrite this. We have 2a e to the 2x plus 2bx e to the 2x and then plus b e to the 2x. So, let's now get the second derivative of y with respect to x. Y double prime equals, the derivative of this term is 4a e to the 2x plus, in this expression or term, we'll apply the derivative of a product. So, the derivative of this is 2 e to the 2x. I-multiply natin dito. So, we will have 4bx times e raised to 2x plus this times the derivative of that. So, that's just 2 times b e raised to 2x. And then plus the derivative of this. So, we will have 2b e raised to 2x. Okay, so we can simplify y double prime and combine like terms. These two terms are the same, so we can combine them. 4a e raised to 2x plus 4b x e raised to 2x plus 4b e raised to 2x. So here, we have two arbitrary constants to eliminate, a and b. Here we have a and b. And here we have a and b. From the given general solution, we have the terms a e to the 2x and bx e to the 2x. And let's call this equation 1. For this y prime, let's call this equation 2. And for y double prime, let's call this equation 3. So notice that in equations 2 and 3, meron tayong term na b e to the 2x. b e to the 2x na wala dito. So we can actually eliminate this term or this term first, itong may e to the 2x na ito, b e to the 2x, and we can do that by subtracting this from equation 3. So what we will do is equation 3 and then minus 4 times equation 2. Y double prime equals 4a e to the 2x plus 4b x e raised to 2x plus 4b e raised to 2x. And then minus 4 times ng equation 2. So I multiply this entire expression by 4. So we will have 4 y prime equals, multiply this by 4, so I will have 8. 8a e raised to 2x, multiply this by 4, I have 8bx e raised to 2x, and then I will have 4 times b to the 2x is 4b e raised to 2x. Okay, so if I subtract these two, itong term na ito magka-cancel yan. So dito ko na lang isusulat ang sagot dito kasi hindi nakasya sa baba. For the left-hand side, we have y double prime minus 4y prime. Y double prime minus 4y prime equals 4 minus 8 is negative. 4 a e raised to 2x and then 4 minus 8 ulit. So minus ulit yon. Minus 4b x e raised to 2x. So, in this equation, ang natitira na lang is yung a at saka yung bx. And this equation is now similar to equation 1. Okay? So, if I multiply equation 1 by 4 and add it to this equation, I can now eliminate the arbitrary constants a and b. Okay? So, what I will do is I will multiply this entire equation by 4. So, 4y equals 4a e raised to 2x plus 4bx e raised to 2x. And then, i-add ko siya ngayon dun sa nakuha ko kaninang equation. So, I have y double prime minus 4y prime equals negative 4a e to the 2x minus 4bx e raised to 2x. Okay, so if we add these two equations, ang mangyayari, magka-cancel ito at ma-eliminate na natin ang arbitrary constants. So I now add 4. So dito naman walang term na may y. So this is just 4y and then I have, wala naman akong ibang y double prime. So plus y double prime lang din and then minus 4y prime equals 0. So this is now your differential equation. Now again, the proper way of writing a differential equation is to arrange them in order of decreasing derivative. So we will write it as y double prime and then minus 4y prime plus 4y equals 0. So we now have a differential equation. So take note that this differential equation is linear. This is a second order linear differential equation, linear in y, and has constant coefficients, 1, negative 4, and 4. Okay? So ngayon, marunong na tayong kumuha ng differential equation kung given ang solution. And sa susunod na module, pag-aaralan natin kung paano kumuha ng solution ng differential equation. Again, sa mga susunod na modules, ang pag-aaralan na natin is paano kumuha ng solution ng mga differential equations. So natural, magsisimula tayo sa mga first order and then after that, pag-aaralan natin yung mga second order differential equations. Okay? So, the next topic will be about family of curves. And that topic is actually similar to this one. So, see you in my next video. Bye!